Every 15 minutes, 50 Americans are diagnosed with cancer. These are alarming statistics, and the stories are remarkable. Some are stories of triumph, and some are not. Some are heartbreaking. But these wave makers are making waves against cancer and giving more chances for hope. Swim Across America has granted more than $100 million since 1987 for cancer research and patient programs. Think of all the lives you've saved by making waves. Hope has no finish line.
3, 2, 1, begin!
There's over 600,000 Americans that will pass away from cancer each year. Those are alarming statistics. The cure to that is to invest in research. You need philanthropy. And in 3 decades, Swim Across America has invested close to $100 million into cancer research programs that have led to breakthroughs in immunotherapy, personalized medicine, gene detection. And Swim Across America has been there providing the seed funding.
All this takes is, put on one of our t-shirts, put on a baseball cap, put on a swim cap, put on, a pair of goggles, and just put your feet in the water, put your toes in the water. That's all it takes. There's nothing about it that is not simple. It's simple. Because of the way we are funding 60 different investigators last year, you don't have to bat 1,000, you don't even have to bat 50%. It's gonna be that needle in the haystack, that one that finds the special thing. And it's not more money that makes that possible. It's just having more chances. I think that's what makes this work. More chances for hope. We are fighting sometimes something that you can't even identify.
You take a gamble, it's part of it. But if no one is going to take a gamble with these scientists, nothing's really going to move quickly. And so that's where I think it's so important that we are the organization in many instances that is seeding these young investigators.
We've been rewarded a millionfold by the inspiration we get from the Swim Across America family. It started out with a small group of friends, and it's grown into a very, very large family. My name is Hugh Curran. I've been a member of the board of directors of Swim Across America and former chairman of the board of directors of 15 years. We've seen so much progress in the realm of research. Our participants through our beneficiary committee, help identify some of the cutting-edge research.
The main goal, of course, is to spread the awareness and raise the money for cancer. The money goes through St. Vincent's Medical Center Foundation, which is in Bridgeport, and really goes out back to the community, which is...
We can look to our past and say, we've had tremendous success with the model. It works. Trust us. We've got the right people, got the right tools, we're giving them the funding. They're going to get it done. And we're very confident that, the gambles that we take will pay off.
Our model has always been act locally, think globally. The money we raise stays in the communities where we raise the money. I can still remember, we were a humble organization, not making a lot of money, and Jedd Wolchok came to a meeting in New York, and he pitched this, immunotherapy. And that was 25 years ago.
The Swim Across America lab at Memorial Sloan Kettering is a wonderfully diverse group of cancer professionals, some of whom are medical oncologists, some of whom are radiation oncologists, some of whom are surgical oncologists. We also have some professional scientists, people who don't have a clinical part to their day, but are full-time bench scientists. We feel very fortunate that people have come from all over the world to work in this laboratory, from Canada, from Mexico, from Europe, from North Africa, from Asia. The most important thing to us is that our group feels the passion to control this awful disease.
Jedd Wolchok is an oncologist and the chief of melanoma. We have been providing funding to his research lab. It's called the Swim Across America Research Lab at Memorial Sloan Kettering for, I think, 20 years now. And so that funding allows his lab to conduct research in and around melanoma, but also the mushroom effect of melanoma, meaning, okay, something works here, it can expand other areas as well. And so he's been a mainstay partner, supporter of Swim Across America for over 2 decades.
An investigator is a researcher who is asking questions, trying to learn, innovate, improve the state of the art, whether a basic investigator, learning fundamental insights into the nature of what is a cancer, and why does it arise, and why does it grow to threaten life, to a translational researcher, how do we use that information to translate this to improvements in diagnosis, detection, treatment, and prevention, to a clinical researcher. Here's a treatment, how do we know how well it works? How do we know what its side effects are? How do we know it's better than what we have so far? And those are the 3 fundamental kinds of investigators who are all cancer researchers.
The immune system is trained throughout our life to recognize foreign pathogens that are a threat to us. The quest that we have now is to understand what each individual patient and their immune system need to best control the cancer. We feel as if we have a foothold now, and the next important steps are to build on that in a person-specific way. When I first started practicing, the average life expectancy of a newly diagnosed patient with metastatic melanoma, so melanoma that has spread from the skin to other parts of the body, was about 6 to 7 months. Now, based upon achievements in immunotherapy and also in targeted molecular therapy, the average life expectancy of a newly diagnosed melanoma patient is over 5 years. That change happened in the past 10 years. That's a big leap.
So I think it has to start with the institutions. I think in the 80s, there was a lot of competition amongst institutions, and there wasn't a lot of sharing of information or participating in the fight against cancer together. And I think over the course of 33 years, you saw the walls being broken down, collaboration amongst hospitals and research institutions, better communication from institutions to doctors to donors to families.
In cancer, research has become much more collaborative. Maybe that's because of technology. Maybe that's because people do move now. I mean, people move from Memorial Sloan to Hopkins to Baylor. We win when we defeat this thing, and I think that's the mindset. We're fighting something so not simple.
When you look back on cancer researchers, you conjure up this image of a lone figure late at night in a laboratory. Anymore, what we're finding is that researchers work much more effectively when they interact with other researchers, because they can interact, share information, share best practices, share data, and work together in more and more collaborative and team science ways to get to the answer, to get to a cure for cancer. It's like the difference in swimming between an individual event and a relay. In a relay, you work together for the victory. And what we're seeing is more and more of that in cancer research.
Another aspect that we've become aware of is the necessity of having colleagues who are expert in the quantitative or computational aspects of our work. Big data is here, and it's real, and it's awesomely complicated.
So I'm Sandy Anderson. I'm chair of the Integrated Mathematical Oncology Department here at Moffitt Cancer Centre. I used to work in a maths department in Dundee, Scotland, which is on the east coast of Scotland, and worked on cancer there for many years. But I was frustrated about not really being able to translate my ideas to clinical change. And I got to meet Bob Gattenby at a few meetings, and he told me when he left Arizona that he would be coming to Moffitt and he'd love to try and start a maths group in a cancer centre. It was a great opportunity for me to take something which had been largely theoretical and abstract and now bring it into the heart of a cancer centre, work directly with clinicians, directly with experimentalists, and sort of drive novel cancer therapies. One of the big issues that we have with cancer is that there's certain things that you can't measure in a patient, that you can't fully know what's going on. But what you can measure is roughly things like the size of the tumour. You can do that maybe with imaging, with certain tools that they can get a rough estimate of what's happening. But what's really hard to do is to know what's truly going on at the cell scale and what are the dynamics within that patient's cancer. So when you treat, you get a response and the tumour shrinks. But if they continue to treat, the tumour comes back and it becomes resistant. So what was clear is we had to change that strategy of just always going for the maximum tolerated dose, hit the tumour as hard as we can. So how could you know what the best strategy to do would be? And that's where mathematics comes in. So one of the things that we've been doing for decades is being able to predict what happens in the weather. So for example, when a hurricane touches down, we can predict the path of that hurricane and where it's going to land, where it's going to hit next. And we can do that because we can describe equations that talk about the motion of fluid, air, pressure, velocity, all of that. And it predicts pretty accurately what the hurricane's going to do. So in a similar way, we take the current state of the patient, size of the tumour, certain aspects that we know about from imaging the state that it's in, and we then predict forward in time how that tumour is going to grow or shrink in response to the treatment. In a computer, we can now simulate 1 million treatments, all the potential strategies, and just like in your hurricane prediction, you get this cone of uncertainty about the hurricane might go this way or it might go that way, then we can have a kind of cone of uncertainty for that patient's tumour and say that to make sure that we get the best treatment strategy for that cone, we're going to shift our treatment to push it a certain direction that'll give us a longer term response. And that's what the equations give us. They allow us to tune the treatments in a very specific, personalised way.
Grow in this area.
We're here in the collaboratorium. We're on a floor that is staffed by mathematicians, physical sciences, scientists, and led by innovative people like Dr. Sandy Alexander, Robert Gatenby, Joel Brown. Here in the collaboratorium and on the 4th floor, Moffitt had the foresight to build a program that addresses cancer. Studying a human with cancer is enormously complex with so many variables. Having an idea of when a cancer might misbehave, starting a therapy and knowing that it's going to fail, but being able to anticipate it and trying to change therapy beforehand and seeing benefit. These are the early insights that we're getting by applying math and modeling to cancer. While there are successful therapies for certain cancers, there are lessons that are shared across cancers that we should definitely be aware of. So I do consider things that work in a certain cancer for the cancers that I care about. I do think that there are a lot of ideas, a lot of successes that can be borrowed across. I think we have to go outside the oncology discipline to find out the next great idea, and that's what we're working on here. And the more and more sequencing and the more information we get from patients, we realize that no two cancers are the same. We still have a lot to learn. An investigator is definitely not locked in a certain area. We're really patient-focused, and we have to build teams around those patients. So it takes a lot of investigators, some really focused and some good at working with teams to formulate the right question and answer it for a better patient outcome. But cancer is unfortunately very similar to the patient. It has a lot of the same genes. It has a lot of the same limits on viability, such that a lot of times when you go to try to kill a cancer cell, you actually end up hurting the person. What we need to have is more complex plans because cancer is more complex. It's not an antibiotic and a germ. It's a living system that has the complexity of the rest of the human wired through its 24,000 genes. It's quite a beast.
But one of the things that we've been doing as we've been building the tools for cancer is in the back thinking about this could also be shared with other communities. And when you get together as a group, there's like 35 people thinking about the same problem in different ways. And that momentum was something that I didn't actually see when we first started IMO, but as it's grown, so has this momentum and this kind of reinforcement of what our kind of unified vision is, which is to deliver, and better understand cancer and deliver better treatments for individual patients.
My job to try to eliminate the cancer in the patient sitting across from me. And to me, team science is the way forward. New ideas, people outside of the classic oncology field, inviting them in, listening, and thinking about cancer differently.
My name is Tim Tsui. I'm a sophomore at Dartmouth College studying economics and geography. So the summer before my senior year, I'd started getting some pains in my knee, but kind of swam through it, didn't really get it checked out until much later. But one day the pain was just too much, so we got an x-ray done, and that's when we learned that it was probably osteosarcoma. We started chemo for about 9 months, and I was officially cancer-free, rang the bell, did my first semester at Dartmouth. And then when we came back for spring break, we did a routine CT, and we realized that it had come back in the lung, which is very common for osteosarcoma. And so that was how I got to Moffitt and how I started working with Dr. Reed.
Tim is brilliant, Ivy League student, very smart. Tim questions things. I love that. Sharp kid.
With Dr. Reed, there's always options that you can always talk about and explore. And so it really gives you that mindset that no matter what happens, I think there's a way. And that's been really helpful in keeping hope. Because that's really, at the end of the day, what's important to keeping you happy.
When we formulate a plan, he challenges. At every single step, he challenges. And it's fantastic. The worst thing to have is a patient who isn't asking questions. The worst thing to have is a patient who's just there.
I think a lot of times we go to the doctor and we kind of trust them on what they're talking about. With cancer research, I think I'm always asking what the research is behind a particular drug. If he suggests a certain path, what have been the clinical outcomes of that before?
So challenging, pushing me, trying to figure out a way around this is what really led to us bringing this idea of evolutionary tumor board, a clinical trial to try to investigate strategies that are eco-evolutionarily informed.
I think the biggest thing is, like you said, he listens, and so he walks through all of the things that I'm concerned about that I bring up, especially if it's a study that we didn't really talk about, that I go home, look through, and say, hey, what about this one, or what about this way? And just getting that perspective and getting his thoughts on that is a lot more comforting for me to know that we've kind of been able to close the doors on some aspects and move forward with one. I know that if I talk to Dr. Reed, we could find new ways and really get the best treatments available.
Wow. Did we really anticipate in 1987 swimming from Port Jefferson, New York to Fairfield, Connecticut and raising $5,000? Like, did we really anticipate we'd be here today? No.
It was a huge risk, massive risk, for Swim Across America to be putting in millions of dollars into the immunotherapy research lab with no guarantee of a payoff. None, other than we think we're seeing progress.
And ultimately, we can help them. And if it's not with groundbreaking research, perhaps it's with other aspects of cancer and how it affects people's lives, particularly people who've survived cancer. Or you think about people who just aren't getting diagnosed early enough. And these are different programs altogether, but these are things I think that we think about when we say to ourselves, where else can we go? What else can we do that's different?
Attending the Swim Across America events is an opportunity to first and foremost connect with the families who come out on a yearly basis to contribute to this cause. Many of them are there in memory or in honor of people who have been diagnosed with cancer.
You can hope for a cure, you can hope for a long life, but you can also hope that your life has had meaning, no matter how long it is. And that hope permeates everything we do.
We need to come at it from a lot of different directions. We need ideas. We need your enthusiasm. We need your support.
Just the awareness that you have an impact, no matter what that thing is that you do. It could actually be going to an event and high-fiving somebody.
I got involved in Swim Across America because of friendship and because it was something that was important in life to give back to our communities. I got involved because of that.